Hey guys, we are going to talk about volume today. So our learning target is that I will be able to identify solids and use the formula sheet to solve for their volumes. So good news is that every formula you need for this unit is going to be given to you on this lovely formula sheet. So you will be using this in class and on the test and on the SOL. So before we get into our 3D solids down here, let's just go over some of these basics, because each of these is going to make up our three-dimensional solids. So to find the area of a triangle, if I look at my formula sheet, I see that area is 1/2 base times height. So I'm going to write that in here for the formula. And then I can just look at what my values actually are. So the base here is 5, and that tells me the bottom is base, and the height is 3. So from that, I can plug in 1/2 times 5 times 3. And when you multiply that in your calculator, you get 7.5 centimeters squared. All right, next we have a square. So our area for a square is just the side squared, because all the sides are the same. So our side here is 6. And we said our formula is s squared. So our area is just 6 squared, which is 36 centimeters squared. Next up, we've got our rectangle. So hopefully you remember that the area of a rectangle is length times width. Your length is 7, your width is 4. So 7 times 4 is my area, which is 28 centimeters squared. And last but not least, we've been doing circles a lot. Remember, the area formula is pi r squared, not the circumference. So our area formula is pi r squared. But if I look, I see that this whole line is 10. So that's the diameter. So I need to find the radius, which is 1/2 of 10. So that's going to give me 5. And then I can plug in pi times 5 squared. If I want to write my answer in terms of pi, I just do this part, so I get 25. Didn't multiply out the pi. And then if you do multiply the pi, you get 78.5 centimeters squared. All right, so now that we've talked about all the two-dimensional pieces that make up our solids, let's talk about volume. So volume, hopefully you've heard this before, but it's what you want to think about is filling the solids. So the amount of space inside a 3D, so three-dimensional solid. So think of filling the inside of these. So our first solid right here is called a rectangular prism. Rectangular prism because all of the sides of it are made out of rectangles. So if you look at your formula sheet, which I know you don't have now, but right here is your rectangular prism, and the volume is just length times width times height. So I write that down, and now I want to write in what those variables are. So I see that the length is 9, the width is 3, and the height is 5. So if I plug those into my formula, I have 9 times 3 times 5. And then when I type that in my calculator, it gives me 135 centimeters cubed. So our units here are cubed because there's 3 dimensions, length, width, and height. All right, just like a rectangular prism, we have another prism here, but the base is not a rectangle, it's a triangle. So you guessed it, this is called a triangular prism. And your formula for a triangular prism is base times height. But you can see here that the triangle is shaded gray with a big B on it, which stands for the base. So in this formula, we actually have to go back to our area for the base, so the area of a triangle. So that's why we did that review in the beginning. So your formula is capital B times lowercase h. But before I can fill in what the capital B is, my base shape we said is a triangle. And so that area is 1/2 little base times height. So for this triangle, it's 1/2 times the base is 6, and the height of the triangle is 4. So if you multiply that in your calculator, you get that the area of the triangle is 12. So my base area is 12. And then I see that the height of my whole prism is 8. So now I plug those variables into my formula. So I have 12 times 8. And 12 times 8 gives me 96. So you also might see the units written like this, 96 cubic centimeters. Just means centimeters cubed. All right, you guys are doing great. Moving on to our next shape. If you couldn't guess what this is, think of history class, maybe ancient Egypt. We've got a pyramid here. So our pyramid, the volume formula, again referring to this formula sheet, is 1/3 capital B H. So when you see the capital B, you know you have to look at the base shape and find the area of the base shape. So my formula is 1/3 capital B times H. Well, if I look at the base here, 11 and 9, it's not a square, that's a rectangle. So my base shape is a rectangle. And the area of a rectangle, which is what we just did up here, is just length times width. So the area is length times width, which is 11 times 9, which is 99. So my capital B here is 99, and my height of the pyramid is 7. So now I can plug these variables into this formula. So I copy down my 1/3 times the big base times the height. I type that all in my calculator and I get 231 centimeters cubed. All right, guys, you are halfway through all these shapes. Go ahead and flip it over. We will finish up volume here. So next up, I've got this lovely cylinder. So your cylinder formula is going to bring in pi and radius because the base of our cylinder is a circle. So our volume is pi r squared times the height. So it's kind of like you're stacking lots of circles in there. All right, so my variable here, the r, the radius, looks like that is given to me as 7. And my height is 12. So now I just plug these into the formula. So pi times r squared times height. And now I want to practice answering it both with multiplying pi out and leaving pi. So 7 squared times 12 gives me 588 pi. Or if we multiply 588 times pi, you get a volume of 1,847.3 inches cubed. All right, 2 more shapes left. This one should remind you of like a birthday party hat. It is a cone, or maybe an ice cream cone. I don't know, lots of different cone-shaped things. So our formula for our cone is right here. It's sort of like our cylinder in that it's got a circular base, but then it goes to a point. So it's almost the same formula as our cylinder, but we add in this 1/3 in the front to account for how the circle goes up to a point. So the circle kind of gets smaller on its way up. If that helps you think about it. So it's 1/3 pi r squared times h. Here my radius again is 7 and my height is 13. So now if I plug these in, I have 1/3 times pi times 7 squared times 13. Again, if I multiply everything but the pi, so in terms of pi I have 212.3, or if I multiply all of it out, including pi, I have 667.1 inches cubed. All right, we've got one shape left, and hopefully you recognize this. All of you who play sports, this is a sphere. Soccer ball, baseball. I guess not a football though. Basketball, you get the idea. All right, so our formula for a sphere is also kind of like our cone and our cylinder. It's got the pi and the radius, but this time we're multiplying by 4/3 because it's got all sorts of different circles within that. So 4/3 pi r cubed. My radius here is 11. I've only got one variable. So now I can just write down my formula, 4/3 pi times 11 cubed this time. And then to type that in your calculator, you're going to have to type 11, and then this little caret button right there. And then you can click 3. So that raises the number to the third power. Hit enter. You get 1,331 times pi times 4 divided by 3 gives me this lovely answer, 5,557. I'm saying that all wrong. 5,575.3 inches cubed. And if we had not multiplied the pi there, left it in terms of pi, it would have been 1,774.7. Alright guys, sorry that was a long video. We got lots of solids to start with, but you've got some problems now at the bottom that you can do for practice. Thank you.